Alright, welcome back everybody. In this video we're going to revisit area. We're going to look at the first few examples from this revisiting area lesson. We already know about the connection between integral and area, so we're going to delve into that a little further now that we know how to find integrals by hand. What we've got to consider when we're finding the total area of a region, we want to use the area that's below the curve as positive area, and the area that's above the curve also as positive area. And so the actual calculations that we make to find total area is a little bit different from just taking the value of the integral. So if we're going to find the total area analytically, we need to go through these kind of steps. We're going to partition the interval by using the zeros of the function. Then we're going to integrate the function over each subinterval. And then we're going to add the absolute values of each of the integrals. Usually we just do this by subtracting away the value of the integral where the area is below the x-axis. So let's go ahead and take a look at example 1 here. We're going to find the area of the region between the curve y equals 9 minus x squared for x between 0 and 4 and the x-axis. So first we consider the curve y equals 9 minus x squared and what that looks like. And that's a parabola that looks like this. And we're finding the area of the region between 0 and 4. Well, this intersection point here happens at x equals 3. So if we go over here to 4, what we're looking for is this area that's between the curve and the axis from 0 to 4. So from 0 to 3, I can just go ahead and use the integral of the function to find that area. From 3 to 4, the value of the integral is going to be negative. It's going to find that area only a negative value. So we're going to have to subtract that away in order to find the total area of the region. So setting this up here, we want the integral from 0 to 3 of the function minus the integral from 3 to 4 of the function. And then finding this won't be too bad because we're going to find the same antiderivative for both of these. We've got 9x minus 1/3 x cubed which we're going to evaluate from 0 to 3, and then we're going to subtract away what we get when we take 9x minus 1/3 x cubed and evaluate it from 3 to 4. Alright, so now we'll go ahead and do the calculations. We've got 9 times 3 minus 1/3 times 3 to the 3rd minus 9 times 0 minus 1/3 times 0 to the 3rd. And then we're going to subtract away this whole thing. 9 times 4 minus 1/3 times 4 to the 3rd minus 9 times 3 minus 1/3 times 3 to the 3rd. Alright, and then we'll do our calculations. We've got 27 minus 9 minus 0 minus 0 minus quantity 36 minus 64/3. Come on, stylus. Don't fail me now. Minus 27 minus 9. So we've got 18 minus quantity, let's see, 18 minus 64 over 3, because we've got 36 minus 18, 18 minus 64 over 3, and that's going to be negative 10 thirds. We do all that calculation. And so we end up with 18 minus negative 10 thirds, which is going to be 64 over 3, or 31.3 repeating. And that is the value of this area. Now there's a second question here. It says, how does this compare to the integral from 0 to 4 of 9 minus x squared? Well, this is larger than the value of the integral, because the integral would count this area down here as negative, whereas this area calculation counts it as positive. And so the difference between this area and the value of the integral is it's going to differ from it by exactly twice this value here. So the integral would actually be 20 thirds smaller than the amount of area that we get here. Okay? All right. Now, if we have a calculator in our hands, we can actually find the area using numerical integration without having to split the integral by taking the absolute value of the integrand, which you see right here. If we take the absolute value of the integrand, it takes any of the curve that's below the axis and moves it above the axis. Now this is not significantly easier than what we did if we're finding the integral by hand. It's probably harder to take the absolute value of the integrand, because then we've got to figure out, piecewise where that absolute value is positive and where it's negative. And so what we did by hand in example 1 is definitely the best approach if we're handling this by hand. But if we have our calculator and we're doing numerical integration, we can do this pretty easily. It might take our calculator a little bit of time, but if I want to find the area between the curve y equals sine of x and the x-axis on the interval from 0 to 7 pi over 2, realize that what we're finding here, what we're finding here is we've got, let's see, from 0 to 7 pi over 2, we've got the sine curve, rolling out like this. And let's see, where's 7 pi over 2? There's pi, there's 2 pi. I actually didn't go quite far enough. We're finding this area here. Well, some of it's positive and some of it's negative, and so if we were doing this by hand, we'd have to split this up into 4 different integrals to calculate the area. There are some little tricks and shortcuts that we could use, but instead, if I just set this up as the integral from 0 to 7 pi over 2 of the absolute value of the sine function, then that's going to calculate that area for us. Because what it does is it takes all of these areas that are underneath the axis and moves them above the axis, and then just takes the integral of all of these positive regions. Alright, so I break out my calculator to do this. So I'll use the numerical integral feature and absolute value of sine of x. Please make note, it's very important that you understand that you're taking the absolute value of the integrand, what's inside of the integral symbol, and not just the absolute value of the integral, if we would put the absolute value signs outside of the integral symbol. Alright, and so I click enter, and now I wait. It's going to take my calculator a little bit of time to calculate this for me. But it's probably more efficient doing this than necessarily doing it by hand. And the waiting is the hardest part. Come on, TI-83, you can do it. There we go. 6.999999. What my calculator is trying to tell me is that this area is in fact 7. And I did that using the numerical integral feature and the absolute value. Alright, that's where we're going to stop this video. We'll come back in the next video and look at examples 3 through 5 from this lesson. See you guys then. Have a great rest of your day.